It's my pleasure to introduce our next speaker. Throughout this industry, the community is grain storage. Some of us move it, some of us preserve it, but the common denominator is the fact that we all store it. And our next speaker has been focused on storage and storage facility throughout his career. Steve Schmidt is a business line manager for T.E. Iverson Company of Hopkins, Minnesota. He oversees all the company's engineering, estimating, and business development efforts and has been there for the past 16 years. Previously, Steve was with PMI in Ames, Iowa, and Normal, Illinois. He has been involved in many domestic and international projects, looking for the best value of grain storage for a number of different clients in the application from the country's elevator to export facilities. He is an agricultural engineering alum from Iowa State University, where you earn both a bachelor's degree and a master's degree, as well as a master's degree in business administration. Please welcome Steve Schmidt. Started.
So we'll try not to have a vote about how long you really want me to talk, but we'll see how this timing works out. Verlin, thank you for the introduction. I appreciate that, and thanks as well to the National Grain and Feed Association and the Grain Journal for the chance to be up here speaking with you today. Grain storage, pretty simple topic. But today we're just going to try to kind of cover some of the basics related to grain storage. For some of you, this may be a refresher. Yeah, heard it, been there, done that. But as we look through this thing, I really want you to try to focus on, what are we doing? Are we stuck in a trap? Are we looking for new and different ways and other items that are going on in grain storage? So I really want to challenge your thinking as you're looking at things through today. So for topics today, I'm going to cover really going to look at what are some of the key factors in selecting your storage options. What are the things you should have thought out ahead of time? We're going to look at the soil component of grain storage. It doesn't have anything to do with what you've got, but I find more and more as we look at projects and some change on the building codes, we're having to spend much more time, energy, and frankly, it's an oftentimes overlooked component of picking out your grain storage. You're going to spend some time on soil, the investigation process, and then some improvement options. Then I selected a couple of storage options, and we're really going to look at those storage options from advantages, disadvantages, what are some of the design considerations, what are the trends that are going on in that industry, some things that are happening now, some things in the future. Going to follow back up then with some safety component discussions that are specific to the grain storage area. And I'm going to really share that last point, kind of a best practices that I see from the design and construction standpoint. I got kind of the bottom line disclaimer, just because I don't talk about something, I do talk about something, there's a lot of storage options out there. There's a lot of different ways it can be done. 45 minutes, I'm not going to cover it all. So exclusion or inclusion is by no means any kind of endorsement of any structure. So to build on, I knew I was going to do this tongue twister, to build on the Bill and Bill or the Bill squared presentation from this morning, you really have to have an understanding of what's your business. Why are you storing it? And Verlin brought up the point, we move it, we process it, but why are we storing it? Know that business and know how that business impacts you. You have the single use, hey, we're just going to capture these harvest bushels. And I hear that frequently, and that is a very big part of your business. We got the flip side too, where you're going to handle multiple commodities to an export facility through that one bin in one day. Those are two of the extremes that we kind of bracketed out. There's not a one size fits all. So you really need to take a look at it and have an understanding for that. And as we look at it and we talk about some of the storage options, and to build on, again, what Bill and Bill talked about this morning, really focus on what are your hold points and where you're going to make the decision. Take a look at here's our business case, here's how we think we're going to make money, get the cost estimate, life cycle cost, look at that hold point to make sure that you've got a facility and a plan forward that's going to make the business plan model work. Once you've got that business case looked together, let's dig into the details. The details are really what's going to drive your selection process when you look into storage options. Fill rates and reclaim rates, and it's been mentioned multiple times through this morning, earlier afternoon, those continue to increase. That puts pressure and strain and stresses on your grain storage option. Additionally, when you take a look at the number of turns per year, the cycle, the movement through that storage bin, we've got some storage bins out there that I swear they're just a large spot in the pipe. You know, they're turning multiple commodities on a day. If you think about the stresses and strains that are going on in that structure, that needs to be a part of it. Jim's going to follow and talk a little bit about our aeration, but are you planning on aeration? And if you're going to get it up front, be a part of that. You got the ancillary equipment, other devices you want to do. We're spending a lot of time, you really should spend a lot of time, on how you're going to plan on getting it out. What's those reclaims? There's a number of great alternatives, and I really want to commend the industry to that continual advancement of what are we going to do to get that grain storage out. The hopper bottoms, flat bottoms, sand fill, kind of that air assist, which is a combination of aeration and reclaim. The sweeps we've talked about a little bit. You got the side draws, front end loader. All those are reclaim options. Each of those have a different capital cost. Each of those have a different labor cost associated. So part of that life cycle cost. Get into those details and take a look at those. Switch gears a little bit here. Soil investigation. I was really impressed with Olheiser this morning, those formulas he had up there, and I didn't get a headache. I appreciate that, Dave. So I tried to go kind of a simple formula to take a look at things. And one of the key simple fundamentals, and I've rounded some numbers up here, but if you look at a column of grain, that's where all we're storing a business. We're putting a column of grain up, and I'm rounding it up to say 50 pounds per cubic foot. Yeah, that's a 62-pound bushel, but I round numbers, easy numbers. That column of grain, if it's 100 foot tall, you need soil capable of handling 5,000 pounds per square foot. It frankly gets to be that simple at the end of the day. The structural engineers can have a slightly larger foundation, different footprints. You're going to get in a lot of different issues, but that's really where you got to start on. What is your soil going to give you from that allowable soil bearing pressure just for the grain storage itself? And then you start to add on the structures. So when you look at the weight of the structures, you know, you got the foundations, you got everything involved, and believe me, you know, a mat slab 2 or 3 feet thick takes away your soil bearing pressure. Weighted tunnels, if you got fill for sand fill, again, that subtracts from what you can do. Attached equipment and actually this physical structure itself, all are part of that combination of what's going into. So once you've kind of got some of that point together, you really have to start, and it's a critique I have on our industry is a lot of times we wait for that soil test to be done too late. So we're really having it out of sequence frequently on the design and construction process. I'm a big advocate of getting that soil test done early. Get those borings, get out there, find the locations. If you're a location, if you have a degree of uncertainty, I'm a big proponent. Go on ahead and get that soil boring, get yourself a starting point. If it moves 50 feet, go do the other soil boring when you get the time to construct. It really helps you in the process. And when you look at that feedback from that soil report, you know, you've kind of got that key line, that net allowable soil bearing pressure. It's not closing time. We're not on bar time. So what is that allowable soil bearing pressure in terms of that 5,000 pounds per square feet? Plus, you pay pretty good money, and the structural engineers need to know a lot more than just that soil bearing pressure. Where's the groundwater at? Yes, differential settlement. You may get one amount of settlement over here, and 10 feet is going to be different. You got to take that into account. You got to understand that. Settlement analysis. Seismic is a big or more concern due to the change in building codes for us, a component of it. Soil profiles, construction, liquefaction potential. There's a lot of components in your geotech report that are key to it. The reason I spend some time on this, while you're talking about dirt and what dirt can do, is at the end of the day, that's your bottom line to where you're getting things. If it's not got what you want for soil bearing pressure, you got a number of different soil improvement options. You know, over excavate, bring back some compacted backfill is a very popular one to get to better foundation down lower in your soil profile. Caissons drilled piers has been real popular in our industry for a number of years, piling. Some of these others are picking up more popularity, and frankly, cost effectiveness is there for them in the grain storage structure in terms of the stone columns, soil mixing, some type of displacement pile. There's another half dozen things that I've seen. I continually learn more and new soil improvement options that are available. As we look at all these soil improvement options, talk about soil bearing pressure. The reason I focus on that in the storage discussion is really the bottom line is you get your best interaction when you got your geotech, talking to a structural engineer, talking to an estimator from a cost standpoint. I don't think maybe less than 10% of the time that we come up with the right first thing to do is usually not the best. And the whole goal of this process is to optimize what you can do in your soil conditions. It's a cost-benefit ratio, taller, shorter, squatter, more cost in the soil. This is a key component in terms of driving your capital cost. That interactive discussion is very key. Frankly, on our side, we almost always get a second opinion on a geotech analysis. Hire a geotech firm, have them do the borings, have them do conclusions and results, but it's one of our standard practices that we use is going ahead and get a second geotech to look at those same boring logs. A lot of times they're similar, but occasionally they're not, and that gives you kind of that opportunity to take a look at things. So now I'm going to talk and switch over to different types of storage options. First, we'll focus on the temporary storage. Just a couple pictures here, many different styles, types, configurations, rounds, ovals, C-shaped, permanent filling equipment, portable filling equipment. A lot of advances and a lot of changes in use in this. As we look at the pros and cons for these different storage options, these aren't saying that this is the best or the only way to do. It's just a part of what you should be looking at when you examine the life cycle cost and is it the right fit for your business model. Specifically as it relates to temporary storage, cost, one of the least expensive ways to get into it. And with that, the three constraints that Bill talked about this morning, time. It gets you time quickly. Also the simple construction, even to the point that a lot of elevators can construct that temporary storage facility themselves. You got transportable equipment options out there that continue to improve. A lot of different configurations, how are we going to fit it on the property, flexibility. You can get to large capacity, these 2-3 million bushel ground piles really are very impressive on what they're doing. And at the end of the day, you're not in general putting a lot of soil bearing pressure. But if you're doing a large diameter pile and then the peak's at 50 feet, go back to that previous example, that's still 2,500, 3,000 pounds per square foot of soil. That can be a challenge. On the con side, they are labor intensive, applying the tarp, portable equipment moving around, the reclaim equipment, kind of that ongoing tarp cost is out there. That's an option, or that's a need that, or cost that needs to be taken a look at. The binoculars, if you've got a problem, you got a hot spot in that pile, it takes a lot longer to get to it than it does compared to other storage options. Really increases the scrutiny that needs to be on place when you're managing grain quality in a temporary pile, and associate with that the time to reclaim. This takes a much larger footprint to get the same amount of storage, so it can become kind of a real estate challenged issue. But as you look at some of these different cons and the pros, the industry is continuing to evolve, better tarp quality, better fill equipment. Those are items that are really moving that along. When you look at it from a design standpoint, you really have to take into consideration an item that I often see overlooked on a temporary pile is when that wall gets up over 4 foot tall, 6 foot tall, how's that individual or those group of individuals managing that tarp up at that height? Back to Paul's discussion point this morning, how often are they moving that ladder around? How easy is it to work? Do they start to get to the point of walking the wall to move the tarp? Really, how are we going to provide those personnel needs? Drainage is important. You get a piece of property, you really need to make sure you get that water falling away from that temporary pile. Aeration designed by a proven professional. There's a couple names of people in this room that I would include in that list. Maybe some I'd exclude in a joking fashion, but really make sure when you're looking at aeration in a temporary pile, to me it's one of the more critical storage applications that needs to be looked at for a good, solid aeration plan. You got to be aware of your neighbors and what they're going to be seeing. As a temporary pile, it's a very visible, especially with corn, Kind of gets bright in the fall colors, people see a pile going up, the neighbor complains. You got to be aware of what you're going to plan for your dust control. What are you going to do on that backup electrical? Every time a good storm comes through, which brings wind, which wants to blow the tarp around, it also blows down electrical lines. It also is associated with potential electrical failures. What your backup means you got in play, whether it's some type of a generator or extra strapping to hold down and make sure you hold that tarp. And again, the whole tarp management, there's a lot of great things going on with the advancements on the tarp. You have to make that personal commitment. You're going to do what you need to as you fill the tarp. Normally that temporary pile filling is one of the busiest times during the harvest season, and last thing somebody wants to do is make sure the tarp's in the right place if you're filling it underneath it. You got to work on the pinch points, make that tarp management a part of your process during filling and unloading. And lastly, kind of that management commitment. Don't know how many merchandisers made it here, but you know, in the merchandiser world, pile's full and it magically stays there. Well, that's never the case for us on the operations side. That pile's there, that should be a daily activity, making sure that we've got everything on top of it. So as we look at trends, and the trends that are currently in place or where things might be headed on the temporary storage, really got this integration of wind speed sensors and aeration levels. You know, there's some things that are really going to go on there, I think, that'll help that out. Mentioned the tarp quality, hold down strategies, portable access catwalks that are on rollers that can move around the edge of it. Really, and then with that, then the center column winch systems, I continue to see good improvements and advances, and really that cost per bushel, really what we're tied into on the mega piles. I really think they've done some great things tied with some better tarp quality. Switching gears over to the corrugated steel storage, just to make sure everybody's paying attention. There's one of these three pictures that doesn't have anything to do with grain. Hopefully you picture that one in the bottom corner. Thank you. We look at corrugated steel storage, same kind of pros and cons as we look at it. You know, the pros, if you look at the different things, it really kind of gives you an intermediate cost level. You really get a lot of value for your dollar without going top dollar when you look at a steel storage tanks. Soil bearing pressure, a little bit lower maybe than concrete storage just because the physical structure is lower. We used to say it was because the corrugated steel tanks didn't go as tall, but that industry continues to defy that logic and take those tanks larger. You look at corrugated steel tanks, they've been around a long time. That corrugated sheet is a very rugged, heavy, and used great structural member at the end of the day. So that simple corrugated sheet is a real good proven technology. And my hat's off to those in the industry that are focused on that. As I continue to see the advancement, there's multiple supplier options. I see their responsiveness to the client request on different configurations, different features. I see a lot of great things going on for that industry. On the negative side, and again, this is one where the industry's proved me a little bit wrong, but you know, there is some limitations on what you can do for peak loading. There continue to be advancements on that. If you're going to do multiple fills, that really needs to be part of the process in having that information communicated. There's no reason a steel tank can't do it, but it has to be a known factor going into it in the design phase. Installation quality control is included is critical, especially during the temporary structural load for the bin jacking. You look at the weights of some of these larger tanks and what we're putting up on jacks and how we're erecting that. It really needs to be taken into account, you know, what happens if that 20, 30 mile an hour or 60 mile an hour straight line wind comes and that bin's up in a sail. To make sure we take that into account. On the steel storage tank side, there's just some economic limitations on their hopper bottoms, just structural integrity issues associated with that. And also then just kind of that high speed side draw. There's a tremendous structural integrity when you take a circle and you put equal forces on all sides around of it. But as soon as you take that same circle and take a force on one side, it doesn't work out. So as you look at that, make sure you've taken into consideration they can do a lot of great things with stiffeners, thicker panels, but if that's not planned for, cutting that gate in for a quick side draw may be the most expensive thing one's ever done. So key issues when we look at the corrugated steel storage that really should be taken consideration on the design side. Paul talked about it a little bit earlier, and I'll have a little bit more section on safety, but that really has to be a component of what's coming into it. This is one area you really need to get all the facts about how you plan on using that structure to the design professional. They've got finite and element analysis, a lot of great tools available to make sure that storage bins fit your needs, but if you haven't communicated your needs, that you're planning on putting another bin vents on, or that you're gonna, you know, that, hey, you're putting up a 20,000 bushel conveyor now, but you're planning on going to 60 in the later. If you don't get those facts in front of it, you really are setting yourselves up for failure. Get that type of information, temperature cables, get that in. And the aeration component, get that associated with the roof loads. Common problem I see is really that criticality of that interior slab, or the area that you get into. More times than not, I just do not see people, hey, we got the foundation down, we got our soil compaction done, we know our ring footing is going to stay in there. Well, yeah, it's the lowest level laborer, we're over budget on soil testing, let's not test the sand that we put in for those interior backfill areas. Still needs to be taken care of, it's still a critical part of that integrity. Going to mention seismic again, and the building code compliance 10, 15 years ago. I don't know that I ever heard that we had to have the seismic calculations for a steel storage tank. That was pretty rare. Now it's coming up just about every time we turn around. So you really need to make sure that they're aware where that location of that tank's going, and making sure we match the fill equipment loads with those peak load capabilities. As I look at some of the trends that are out there, and we see what's coming for this industry as a whole, there are some design challenges. The industry is responding to them. The generally accepted code that they were designed to used to be the International Building Code in '97 version. Right now we're on UBC, Uniform Building Code, and now it's to the International Building Code, which is 2009. It's got a whole different set of calculations and methodologies that some of us legacy guys don't understand. Fortunately, we can hire people that do understand those kind of things, but your seismic considerations are there. As we look at the larger diameter bins, it's okay to ask the questions about the roof design. That is a critical area. It's getting taken care of, but you know, we are pushing that limit there. Especially on the taller bins, you know, look at those laminated multiple thickness sheets. Access catwalks. I see more and more better quality access catwalks, more access points around the eave, more access points are actually a walk platform rather than other methods to seeing and getting to vents. I think that's a great trend. Larger access doors, Bobcat skid loader doors, they've really done a great job in this industry of responding to how are we going to get some of the larger equipment in. Good structural framing requirements there, but it's not easy to do. And so it's a trend that's come along. I continue to see a lot of great improvements on just that quality of that fastener. That bolt's a key component of the integrity. The life of that bolt, better structures with that. Options on galvanizing thicknesses, changing and stiffener design. A lot of great advancements and continue improve on that. And then just a continuous improvement in the zero entry sweeps. Getting our point to that zero entry bin. I put the point up here, future steel price escalation. I'm going to deflect a personal story that every quarter I get a commodity price projection in our company. And every quarter it says steel prices are going to spike 4 quarters out. Well, I've gotten that same projection now for 2 years. It is an industry that is sensitive to steel pricing. So as you look at planning, as you look at budgeting in this arena, be aware that that has a little bit more fluctuation. Right now, you get into the steel industry, you get into the detail, steel in China is getting to the market below their cost. That's a world economy, that's helping out on steel pricing. Will that last? Obviously not. So there will be change there. And again, on the trends, the larger, you know, in terms of the competitiveness, when do you want to steel storage versus the cost of a concrete storage? You know, the larger tanks are very cost competitive with the larger tanks on the concrete side. Concrete bins, and here I am talking about putting jump form and slip form, 2 different methods, but I just put the 2 together. Here you see kind of a combination of those styles of concrete bins. When you look at the pros and cons, you know, these bins are really built for that high throughput capabilities. long life, working with the client with some people here that, we got 80, 90-year-old, these are old bins. They will hang around for a long time. That concrete just stays with you. A lot of flexible configurations. I'm always impressed, it seems like, with the different things we come up with over the years. Dave showed the picture earlier of a 6-pack, 9-pack clover leaves. We fit a lot of different shapes, a lot of different sizes. We're on the slip form side. Because of the integral design and because of the wall and stiffness of a wall, this industry on the concrete side is able to take a higher roof load capacity than compared to the others. And additionally, because of more integrity in the wall, hopper bottoms and sand fill, you've got more variety of options and capabilities. On the con side, it's not cheap. This is not your most cost competitive way to get $1 per bushel one turn. Much better ways to do that. Additionally, with it, just the time for construction. Getting to the efforts, heavier soil load bearing capacity, building the forms, getting the forms in. The other two storage methods I talked earlier are much quicker to capacity. And then finally, compared to the others, the concrete, the weight of the concrete, we will go to taller heights to be most cost effective. We'll get up into that preferred 6, 7, 8,000 pounds per square foot is our preference on the concrete bin side of things. Key issue is design. Not unlike the steel, we still have to look at what are the confined space tie-up points, what are the extraction strategies. I'll deal with that more again. Same on the steel side. Get all the facts to the design professionals. Yes, you can with temp cables. If you think you're just going to attach them to the middle of a concrete roof and not get them over the roof beam, they have a potential of pulling down part of a concrete roof. It does happen. So get that information into play. Aeration coordination. Most local building code officials, especially on the seismic side, have a hard time understanding a concrete structure like this. They keep asking, how many floors does it have? Well, it doesn't have any floors. So get to that building code official. And then even though you might think, yes, it can handle a lot of heavy equipment loads, not throughout the whole roof. There's roof beams up there. You need to make sure you get those roof loads and that coordination of the equipment side of things in with that. As we look at the trends, on the concrete bin side, ACI 313 is somewhat of our Bible. Looking at it, so that's going to have a change coming up here projected in 2014. Don't see a lot of change. Change on the building code, the seismic code requirements, they've become more challenging to go on and get that seismic issue through there. So you can see more and more demand for the shipping bin concept. Again, just what seems like a white spot in the pipe, where single bin has filled multiple commodities several times during the day at export facilities. See more and more requirements on asymmetric loading. Hey, we think we just want to fill it on this one quarter, and 5 times a month we want to pull out 20,000 bushel per hour at this side tap over here. That can be done in a concrete bin, but let's have a plan for it. There's many other viable storage options, and this list could probably go on because I sure don't know them all. You got the pre-engineered metal buildings that are a phenomenal structure when it comes to putting up a good, safe space. You with fabric covered hoop buildings, coveralls, whatever the case we might want to call them. The domes are great storage options. I'm surprised how much internationally the storage bag concept is actually a pretty good concept, and that's not exclusive to just international. And still the smooth walled steel tanks. A number of different options other than these 3 that I talked about. Spend some time on safety, and this is safety specifically regulated or specifically designed on the grain storage side. So you all been sitting a bit, so let's have everybody stand up. You can do all that, I think. Get the creaks out one way or another. Maybe even do a little stretch and flex. Here we go. All right, now this is a participatory part. If I could have this group on this side of the aisle, if you all could go on ahead and sit down. You got to remain standing here in the corner here. He'll get it. Then if I could have this middle table here, if I could have this whole group of individuals, you on the far side stay standing up. Yeah, you're welcome, Bob. You got to sit down. We talked about the onset. We have roughly 350, 360 people here. Hopefully they're all here. Take a look at this exercise. according to National Public Radio, and there's various statistics are out there, over 180 people have been killed in the last 20 years in grain entrapment processes. So whether you're sitting down or standing up, the other half of the room, those are individuals that are no longer with the grain industry. That's how large of an issue that we got to be talking about dealing with. You guys go on and sit down. I appreciate it. You know, just this year there's been 9 fatalities, even in grain entrapment. Yes, this does include some Alms Farm statistics. But frankly, it's just something that we've all got to get better at and being a part of. The personal entrapments, the structural failures, those types of hazards are extremely preventable. And as you look at the personnel entrapment, what needs to be done, everything needs to be done as possible related to getting down to that zero entry. As Paul talked about before, engineer out design, engineer out the reason that that personnel has to enter that confined space. So looking at your reclaim system, aeration, do your best at what you can do with that. The training process related to confined space is a good training process that needs to be done, even if you don't think they're ever going to have to enter that space. Recognizing the hazards, recognizing the tools that they need to be going through relative to that training space. Storage system designed for the anchorage points and storage system designed for adequate exit points for retrieval, size, opening, those kind of things. There's no reason it can't be done. And for a lot of the trends we're going towards, it's frankly becoming a standard, and I'm happy to see that. There's some upcoming standard revisions that the American Society of Agricultural and Biological Engineers is looking at. It's a standard 624, not final yet, in committee votes. This is a standard that's really going to be looking on the best practices, what needs to be done for retrieval means, size of openings, anchorage point. Pay attention to the evolution of the standard, and I really would have the expectation that anybody that's looking at a storage system, that this standard is a quoted standard for the design and installation of that system. There's just no reason not to. And this is not just a storage bin problem. There's still a potential for entrapment. There are stories where flat piles or buildings, still very possible for personnel to become entrapped. On the structural failure side, I haven't done a root cause of all, but a lot of them really get down to a mismatch between what that structure was originally designed for versus how it ended up getting used. Spend the time on that design phase. Make sure that design professional that's doing the structural engineering knows how you intend to use that facility, a side draw or not side draw, asymmetric loading, bin top loading, all those cases. And then demand professionalism in the design. You know, it's an okay question to ask who's doing the design and what's their experience and what's their background. That is a very acceptable, and actually it's a question I'm embarrassed when we're not asked that. And then use the flat bottoms as intended. You know, we as an industry have had a lot of success and built a lot of great storage structures. The flat bottom with that center draw gate, stay with that center draw gate until you got that flow. Do not cheat, go to the edges. Even to the point, you know, it's not it's actually a best practice I had. If I'd have a facility, I'd go on ahead and put a lock on every other gate and make it be a management decision that if you're going to have a large flat bottom steel tank and use anything other than the side draw, that's an executive level decision to start to open up those extra gates, because that will cause that asymmetric loading. And frankly, I'm embarrassed on the number of facility structural failures I've seen because the individual didn't even know, went in the tunnel, walked and opened the first gate, and in effect pulled a bin down. We just cannot allow that kind of thing to happen. And if you're going to do that asymmetrical side draw loading or only load it in the corner, just make sure you only do that when properly accounted for and designed. And it can be, but not every bin out there is set up to do that. So don't make any type of assumption that it is. We're going to wind down here is really just what I look at is what are some of the best practices when you look at designing of a grain storage structure. Really begin with that safety as your top priority. Take a look at what is your personal access, what are you going to be doing around that. Stay current with the changing technologies. I learn something every time I come to a trade show event or speak with my peers about the changes, the evolution. Spend the time, energy, and effort to keep up with those storage options. This is part of that challenge from before. What used to work yesterday, there's probably a better way today. These are great opportunities to learn about that from the industry. Mentioned it earlier, that integrated approach to design. We've built many facilities where the geotech, the structural engineer, and the estimator were literally in silos. Yes, the facility got built, but probably not the best value facility. You really need to have them on the phone, same time, look at costs, look at options, and specifically on soil improvement options, I really urge you to take a look at more than one way. Run it to ground, soil improvements on the stone columns, you know what the case on piling costs might be, but run a couple options to ground. You'd be surprised what you might find out. More and more we're seeing the local building official and the issues associated with that being involved in the design. We've approached it both ways, keep them in the dark, tell them to trust our calculations, and got mad when they challenged us. We've gone the other way of meeting with them early, getting the PE stamp to meet with that building official before there's even anything to review. We really have found that that first approach, although not perfect, some building officials will not like, and some building officials will know about venting guidelines, not requirements. But meeting with them early, communicating them your design process, communicating with them your intent on using this facility will go you, by and large, great benefits down the road. Last component here is really on the trust but verify construction adherence. Goes back to the nuclear age, wherever you want to say this, trust but verify. The design is complete, but let's make sure during construction phase, with no critical phase, really jumps into that. As we look at these best practices and storage options, you know, is it a flat, temporary pile? Is it a building? Is it a dome? Steel tanks, concrete tanks? Just a personal story, just finished a feasibility study for a grain company that was looking at a new truck-to-barge terminal. We looked at all those options, and at the end of the day, it ended up being a combination. You know, what's made it past the next business decision? Combination of concrete, steel, and temporary pile. So that just goes to evidence that each has their need, each has their application, and should be taken in, and need to keep that open mind as you look at that. So a little bit of credit here at the end. A lot of these comments and inputs, I thank Stu Ellis and Grain Journal, who interviewed about a dozen industry professionals and got that information to me. I really do appreciate the time and energy to put that together, and then thanks to all of you for your attention.